हमने डिस्कस किया था कि वाटर वी टॉक्ड अबाउट वाटर आयनाइजेशन. ठीक है. I told you everything happens in water. सब कुछ, all reactions, pretty much particles are floating around in water, and because of that, you have so what you have is water ionizes, and when it ionizes, it produces two ions. One of them is OH minus one, the other one is H3O plus one, hydronium ion. That is often referred to as H plus one. Okay. So water ionizes, produces two ions, and what an acid will do is that the acid will increase the quantity of H plus one ions. The base will decrease the quantity of H plus one ions, and vice versa, increase the quantity of OH ions. और मैंने वो बताया था कि इसकी importance कि it's pretty important कि you know how to track these two ions, because the reactions will depend on this. ठीक है. Every reaction, this particle A and particle B, if they're reacting together, they would depend on this, and some reactions would require more H plus one ions or H3O plus one ions, and some of them would require more OH ions. So ये हमने पढ़ा था, and I told you that under standard conditions, the quantity of OH ions that are produced in water, that's 1 times 10 power minus 7 mole per dm cube, and the quantity of H3O plus one that's produced, that's 1 times 10 power minus 7 mole per dm cube as well. तो बहुत ही कम quantity है दोनों की. It's almost negligible. So water ionizes very weakly. That means this equilibrium is favoring the reactant. It's not really producing a lot of products. Jitna higher temperature karoge, it's going to be more ionization. Then I told you about Kc, that you can apply Kc to it, equilibrium constant, product concentration over reactant concentration, since it's an equilibrium reaction. The product concentration divided by reactant concentration. You don't write water in the expression because water is in large excess. And remember, aqueous solutions can the water is never written in the expression because water will be in large excess. The water ko to aapne likhna nahi hai. So that leaves you with your expression, which is you call it Kw then. That's a water constant, that it's HCO plus one concentration times OH minus one concentration, or you can call it H plus one times OH minus one. Kw is an equilibrium constant, so it only changes with temperature, and jitna zyada temperature hoga utne zyada ions honge, so it's going to have a higher value. The value of Kw we calculated was 1 times 10 power minus 14, because H plus 1 was under standard conditions 1 times 10 power minus 7, and OH minus 1 was also the same. And this value is always a constant, whether it's acidic, so H plus 1 zyada ho jayenge, OH ions kam ho jayenge, but the product will still be 1 times 10 power minus 14. Whether it's basic, so H plus 1 kam ho jayenge, and the OH ions will increase, but the product will still remain 1 times 10 power minus 14. Mole square D minus X. So this was Kw. और फिर मैंने explain किया था कि since you have to monitor pH, because all reactions, they depend on the pH. They depend on how much H plus 1 and how much OH ions a solution has. So you have to track it, you have to plot graphs, और graphs के लिए मैंने कहा था कि सबसे अच्छी चीज जो है ना वो log है. और वो log मैंने explain किया था कि log converts like big ranges into small whole numbers. ठीक है. Log of 100,000 is 5. Log of 1 billion will be 9. Log of 0.1 times 10 power minus 12 will be 12. So log just converts the whole scale into like nice, neat numbers. So you take log of the expression, and what you get is minus log. I mean, you take minus log of the expression, which is what you eventually get is minus log of HCO plus 1 and minus log of OH minus 1, and that's minus log of 1 times 10 power minus 14. That's basically equal to 14. Or at the end of the day, मैंने कहा था कि this thing is called pH. The negative log of H plus 1, that's called pH. And the negative log of OH minus 1, that's called POH. And that's equal to 14. So you have an identity which is pH plus POH is equal to 14. And this is how you're going to calculate pH. pH is minus log of the concentration of H plus 1 ions. ठीक है? तो ये clear है, ये जो last part, is this all clear? ये सुनो, ये वाला part clear है? so what I'm going to do now is I'm going to try and calculate. So I'm going to try and calculate pH for pH for strong acids and bases. Okay, that's the first part. I said now for strong acids, calculating pH is pretty easy. Okay, if you have a strong acid fully ionizes. So strong acids and bases, they fully ionize, which basically means that if I have HCl, if I have HCl and HCl ionizes, it's going to ionize fully. It's going to produce H+1 ions and it's going to produce Cl-1 ions. अच्छा ये याद रखना कि this is not the actual equation. The actual equation is that the HCl is going to ionize and it's going to produce H+1. लेकिन मैंने explain किया था that H+1 gets attracted to water and that H+1 ends up forming HCO+1 ions. So the thing that you call H+1 is actually HCO+1. So the actual equation, although we often use the simplified version, we mostly use the simplified version actually. लेकिन ये mind में याद रखना कि it's a reaction that happens between HCl and water. ठीक है, जिसको आप simplify करके लिख लेते हो कि it's HCl ionizing to form H+1 aqueous and Cl minus. So just remember that H+1 जो aqueous है ना, that there is no such thing as H+1 aqueous in solution. वो जो H+1 है ना, it goes and bonds with the water molecule. यानी ये हो रहा होगा कि HCl is a polar molecule. और यहाँ पे ना water है, ठीक है. Water has, मतलब water को दूसरी साइड पे. अच्छा, water has, अच्छा HCl water में ही क्यों आयनाइज करता है? The reason is कि वो जो H था ना, that's positive, that's kind of positive. Cl is slight negative. So this H over here, it's going to be attracted to the lone pairs here. तो वो अपने इलेक्ट्रॉन जो है ना उनको वो छोड़ देगा, ठीक है. It's going to, those electrons will get repelled. The negative lone pairs will repel the electrons over here, and the end result is that this H will bind with the water molecules. ठीक है. So the HClH, ये जो है ना, sorry, ये वाला जो है, this would leave, this will get repelled, and your H over here will eventually form a dative bond. This H+1 over here will eventually form a dative bond with the water molecule. और ये जो है ना, this other part, this will actually become Cl-1 because it got both electrons. तो ये चीज हो रही है, ठीक है. So just remember, this is a simplification that HCl ionizes to form H+1, but remember that H+1 is in reality H3O+1, ठीक है. ये part clear है? Is this clear? और अच्छा, लेकिन हम बस माइंड में रखना, हम यही इक्वेशन यूज करेंगे, but just remember it's actually the real equation is this one. So anyway, so HCl is a strong acid, and strong acids and also strong bases, they're fully ionized. What does that mean? That means that if I have 0.2 mole per dm cube of HCl, so that means the amount of H+1 ions in the solution will also be 0.2 mole per इन इसको पानी में डालोगे ना, it's going to fully ionize. Now there's one assumption that we're going to make. Okay, when you put HCl in water, remember water also ionizes. लेकिन water का हमने क्या पढ़ा था कि कहाँ गया water हमारा? हाँ ये. अच्छा, water also ionizes and water already has some H plus ions, right? लेकिन उनकी जो quantity है ना, that's very small. That's 1 times 10 power minus 7 mole per dm cube. So whenever we add an acid to water, our assumption will be that okay, water से जो H plus होंगे ना, they will be negligible. Like very few ions will be produced. So when I say that I want to find out how many H plus ions are produced by HCl, the most of those H plus ions will be coming from HCl itself because it's a strong acid. It will fully ionize. Water की तरफ से जो quantity of H plus होंगे, they will be very very small, and so we can kind of ignore that. Is this clear? This part? तो मतलब मैं इसमें ऐड भी कर लेता हूँ कि negligible ions they come from water, are produced by water. So very, very few ions will actually be produced by water itself. So pH निकालना है, that's pretty easy. कि pH का formula हमने किया था. pH is, what is pH? It's minus log of the concentration of H plus 1. That's about it. So you can just find pH. What is the pH for this thing? It's going to be, so it's going to be so it's going to be pH is the negative log of the concentration of H plus 1 ions. And in this case, it's going to be negative log of 0.2 mole per dm cube. So can anyone tell me what the pH is? ये मुझे बताओ क्या वैल्यू आ रही है? So it's coming out to be 0.7. So that means the pH is 0.7. That's your pH. Okay, that's it. So it's pretty simple. But minus log of the concentration of H plus ions. Let's do another one. I've got nitric acid. अब जो nitric acid है ना, that's also a strong acid, and it will fully ionize. So it's going to produce H plus 1 ions and NO3 minus 1 ions. So that too is a strong acid, and uski bhi koi concentration le lete hain. Let's say I've got 0.0001 mole per dm cube nitric acid. So it's a strong acid, it will fully ionize. So the quantity of H plus 1 will also be exactly the same, 0.001 mole per dm cube. pH निकालना है. What is the pH? It's negative log of the concentration of 0.001. So what value do we get? So we're getting 4 for this. The pH for this one is 4. So एक तो वो याद रख लो कि pH larger means smaller H plus 1 concentration. Why? Because powers में ना तो this is 10 power minus 4 actually. So because we have got a minus sign, तो वो actually plus 4 हो जाता है. So जितने वो decimals ज़्यादा होंगे उतना the number is going to be bigger in size. So higher pH means lower concentration of H plus ions. Smaller pH means almost 10 power minus 1. अगर 0.1 होता था, it should have been, the pH would have come out to be 1. तो क्योंकि वो powers में जितने ज़्यादा decimals होंगे उतनी power बड़ी होगी, ठीक है? That's why bigger pH means smaller concentration. Achha, this is easy. It's ये clear है सारों को? Is this clear? Lisha है ना? Haseeb, Shian, सारों को clear है? Reid, is this clear? So what about bases? Now I've got a strong basis. So how to calculate pH for strong bases? As a for strong bases. Now in this case, for bases, you don't actually calculate pH. Your bases don't have H plus ions. Bases ulta kaam karte hain. What bases do is, like if I have a strong base, I've got NaOH. So NaOH is a strong base and it's going to ionize fully and it's going to produce Na+1 and it's going to produce OH -1 ions. So if this is 0.02 mole per dm cube NaOH, then I'm actually going to focus on the OH ions. The OH ions concentration will be, it's going to come out to be the same 0.02 mole per dm cube. So we actually calculate OH ion concentration. We don't actually calculate H plus, because we can't calculate H+1. वो दिया हुआ ही नहीं है तो पता कैसा लगेगा. And instead we actually calculate POH now. You've never actually heard the term POH, but basis ke liye you actually calculate POH. POH, as we had talked earlier, was what? It was, so that one was the negative log of the concentration of OH ions, right? And that's equal to the negative log of the concentration of, in this case, 0.02. Kya value aa rahi hai iski? What do I get for this? किसी ने किया? अच्छा, इसकी वैल्यू आ रही है 0.02. That's so you're getting 1.7, right? So POH, and we have never actually heard of POH, right? So what you do is, remember मैंने कहा था कि अगर if the OH ions, this is what we studied, right? So we're going to bring in KW over here. हमने कहा था कि अगर OH ions ज़्यादा होंगे ना, the H+1 will actually be lesser. But the product or the equilibrium constant or KW will still come out to be 1 times 10 power minus 14. Okay? So if the OH ions are greater, the H+1 are lower. So what we're going to do is, since I've already found out POH, I have this relationship that pH plus POH is equal to 14. So based on this, I'll be able to calculate pH. So based on this, I'll be able to.
Sir, I have a question.
Yes.
If the concentration of hydrogen ions increases in acid, does the OH ions concentration naturally decrease?
Yes. What is the first thing they will do? Let's say the hydrogen ion concentration increases, right? So a lot of those hydrogen ions will react with the OH ion and they'll neutralize it. The equilibrium will shift backwards, right? So what will happen to the concentration of OH ions, which was already pretty low? It's going to become even lower now. Okay? Is that clear?
Okay, got it. Yes, and in the KW, we don't consider we consider water as 1 when we do the KC?
We consider water as 1. We consider it as a constant. Okay, water.
Okay.
Remember, KC, you studied that whenever there's an aqueous solution, water, any substance that's in large excess in a reaction, its concentration is practically constant. Like if you have baki, let's say A, B, C, D are reacting together and all of them are 0.1 moles, or बीच में एक substance है which is 10,000 moles. तो अब अगर उसके 0.1 moles थोड़े से ज़्यादा बन गए तो उसकी concentration में तो कोई फर्क नहीं पड़ेगा ना. It's practically constant. Like if you have 10,000 moles already, and there's an extra 0.1 mole getting produced. So the concentration of a substance that's in large excess will always be constant. Is that clear? तो उसको 1 ले लेते हैं, ठीक है?
Yes.
Solids का भी 1 लेते हैं. Aqueous solutions में water is taken as 1. ठीक है? Keep that in mind. So, and you start calling it Kw. You have the same expression, you just call it the water constant. So the thing is that if you have pOH, okay, so we've got a relationship which is that pH plus pOH is equal to, yani this becomes 14 minus pOH, which in our case is 14 minus what, 1.7. And if it's 14 minus 1.7, that will be what? 13.3? No, it's 12.3. Okay, so my pH comes out to be 12.3. Is that clear? Or Ismena, that's just remember that what you're going to do is you're going to calculate pOH first for bases. And then you're going to calculate calculate pOH first and use that to calculate pH. Using this identity, which is pH plus pOH is equal to that means it's a very alkaline solution. What does 12.3 actually mean? It means, remember, we're not. I did explain to you that why don't we actually talk in terms of pOH? So the reason is it's just convention. I mean, you could have calculated pOH and you could have talked about it in terms of pOH. Because it's important to track just one of them. Like the other one is exactly the opposite. Like if you know that H plus 1 is higher, then obviously you know that OH ions is going to be lesser in quantity. If you know that H plus 1 is lower, then automatically you know that OH ions will be in larger quantity. Okay? So you just track one of them. You just track pH. You don't actually track pOH. Okay? So that's why everything is done in terms of pH. Or my understanding, you see that develop हुई भी है. You don't actually have to calculate pH. You can just look at pH and that will give you an idea. But anyways, what does 12.3 mean over here? That means that H plus 1 has a very, very low concentration. Because obviously it's an alkaline solution. अगर मैं इसको reverse करता हूँ ना, like if I take the anti-log, remember what does log do? It expresses things in powers of 10. So the concentration of H plus 1 over here is 10 to the power minus 12.3. Okay, so and remember, you make sure you know how to convert something from log back to this thing. Okay, बल्कि इधर कर लेते हैं कि how do you convert it back? This thing is minus log of. So this thing is minus log of the concentration of H plus 1 ions, and that's equal to 12.3. You take the minus sign to the other side, so it becomes log concentration of H plus 1 ions, and that's basically equal to minus 12.3. Anti-log later on, basically the whole thing becomes in powers of 10 back again. It's 10 power minus 12.3. So it's pretty simple. What you just have to do is, if pH given, whenever pH is given, you want to go back. H plus 1 is going to be 10 power, minus sign is the minus log, that it will become 10 power minus 12.3. If they say pOH, and you want to go back and you want to find out the OH ion concentration, all you have to do is it's 10 power minus 1.7. ठीक है, तो ये वो detailed calculation है, but the simple method is 12.3. That means 10 power minus 12.3. So if you have a higher pH value, that means the concentration of H plus 1 is pretty low. It's like really low. Minus 12.3 power, so that means it's extremely low concentration. Okay, so very low concentration. And that by default also means कि वो बहुत ज़्यादा है. Okay, that means that there's going to be very high concentration of OH ions, even though you're not tracking it, but you'll obviously understand. Okay. So we always track H plus 1. We don't track OH ions. Like it's obviously understood. Okay, if you've got a very low concentration of this thing, then it automatically means you've got a very high concentration of OH ions. Is this clear? ये चीज क्लियर है सबको? अभी अब अलीशा है ना? Athena, is this clear? अच्छा, लेकिन माइंड में ना you have to नहीं, Alicia, can you calculate the concentration of what? अगर pH given है, you can calculate the concentration of OH. Let's do another question. ठीक है, let's do more questions. Just make sure that basis के अंदर ना you deal in pOH. लेकिन again, we're not interested in pOH, so we convert that pOH into pH because we always track the pH. We don't track the pOH. So let's do more questions. Let's say there's another base. मैं उसका reverse कर लेता हूँ. Here's a base and that's KOH. And they say that there's KOH, which is a base, has a pH of, let's say, 13.1. Like it's strongly basic. So it's got a pH of 13.1, and they're asking you to find KOH concentration. Like what is the concentration of the base? So what I'm going to do with this is, I know that KOH is a strong base, so it ionizes completely. And it's going to produce two ions. One is K plus 1, and the other one is OH minus 1. ठीक है, ये दो ions produce होंगे. And the other thing is that, so let's say it's X mole per dm cube. Then the concentration of OH ions will also be X mole per dm cube. As it's also going to be X mole per dm cube. But the thing is, pH is given. What do I do with pH? I remember for bases, you don't deal with pH. So pH is 13.1. We know that pH plus pOH is equal to 14, right? So what I can simply do is I can calculate pOH. What is pOH? It's going to be 14 minus 13.1, and that will give me 0.9. So I know that my pOH is what? It's 0.9. और इसको अब एंटी लॉग लोगे ना, it's if you want to take the reverse, या तो डिटेल में रिवर्स ले लो कि जी minus log of what is pOH? It's minus log of the concentration of OH ions. ठीक है, that is what P stands for. अच्छा, बल्कि ये याद रखना, कि जो हमने यहाँ पे किया ना, remember this, P stands for minus log. You're going to take this P in many different areas, ठीक है, हर जगह apply होता है. So they very often take this P. It's not always pH, it's not always pOH. किसी भी चीज से ज़्यादा you can just write P. The P means minus log. Then you're taking negative log of that thing. तो अगर आपके साथ कोई इक्विलिब्रियम कांस्टेंट है PKC लिख दिया ना, that means they've just taken negative log of that particular thing. तो P का एक तो मतलब समझता है, it's just negative log. It just means negative log. But going back to the question. Going back to the question. POH, that's the negative log of the concentration of OH ion, and that's equal to 0.9. पहला काम क्या करोगे? It's going to be log concentration of OH ions, that's equal to minus 0.9. जब anti-log लोगे ना, you do the reverse. So the OH ion concentration will be, it's 10 to the power minus 0.9. यानी वो पहले स्टेप्स में भी कर सकते थे कि whenever you see pOH 0.9, that just means that the OH ion concentration is, I mean, that will be quicker if you just remember कि you can just skip the math. It's just going to be 10 to the power minus 0.9. That's it. ठीक है, अगर आप वो habit बना लो, whenever you see pH 0.9, you want to get rid of the P, just make it 10 to the power minus 0.9. अच्छा, anyway, so what is 10 power minus 0.9? ये कोई मुझे बता दे कि I found out the concentration of OH ions. What is this value? क्या आता है 10 power minus 0.9? किसी ने किया ये कैलकुलेटर पे? कितनी आई है? That's coming out to be 0.126, right? So that means the concentration of OH ions is actually 0.126 mole per dm cube. And since it's a strong base, तो ये भी वही है, that's 0.126 mole per dm cube. So just remember that we're always tracking pH, but remember there's a thing called pOH that also exists. You just don't talk about it, but it's there. Basis के लिए you always focus on pOH, even though pH might be given, just यहाँ पे pH is given 13.1, but you're going to quickly calculate the pOH. You don't actually deal in pH. pOH निकल आएगा तो उससे फिर OH ion की concentration you'll be able to find out, and you just take the inverse log, and once you have that concentration of OH ions, you can figure out the concentration of KOH. So at the end of the day, for strong acids, strong bases, just remember, okay, there's a thing called equilibrium constant. ये वाला. तो या तो आपको, if you know H+1 concentration, you can use this identity and you can figure out OH ion concentration, or you can do the whole thing in terms of log. If you know pH, you can find out pOH. If you know pOH, you can find out pH. नहीं, 0.126 वो 10 power minus 0.9 था ना, ये आप ये वाला पार्ट कि क्वेश्चन में था कि pH 13.1 है ना, तो और KOH था, बेस था, so what I did was I quickly calculated pOH, which was 14 minus 13.1, that came out to be 0.9. तो मैंने उसका फिर P हटा दिया क्योंकि P is minus log of the concentration of OH ions, that's 0.9. तो वो OH ion concentration जो है, that will be 10 power minus 0.9. So I'm taking the inverse log. ठीक है, log 10 की पावर से एक्सप्रेस करता है, उल्टा कर दो तो वापस 10 की पावर पे वही चीज डाल दो. ठीक है, तो remember this, pOH is equal to 0.9. So OH ion concentration will be 10 per minus 0.9. And that came out to be 0.126 mole per dm cube. तो ये यहाँ से आया. ठीक है, is this clear? चलिए, कोई क्वेश्चन नहीं है इस पे? इसके मतलब और क्वेश्चंस प्रैक्टिस करेंगे नेक्स्ट टाइम. But is this clear? Read clear? See.
Yes.
Wait a second. We use 14 because no, we don't use 14. 14 जो है ना वो एक जगह से हमने derive किया था. That was KW. 14 की कहानी जो है ना, that was, it started over here that you had मैं 14 की जरा कहानी बता दूं कि 14 की कहानी इधर से स्टार्ट हुई थी. that when you have water and most solutions are water ionizes, produces two ions, OH ions and H plus 1 ions, right? So the concentration of both ions is 1 times 10 power minus 7 mole per dm cube. When you calculate the equilibrium constant for this ionization of water, you figure out the expression came out to be H plus 1 multiplied by OH ions. And since both of them under standard conditions have a concentration of 1 times 10 power minus 7 mole per dm cube, तो उनका जो product होगा ना KW, that's going to give you 1 times 10 power minus 14. Okay, it's going to give you 1 times 10 power minus 14. And I told you that this constant is always a constant, that if you add an acid, H plus 1 goes up. If you add a base, the OH ions go up and the H plus 1 go down. But the product will always be 1 times 10 power minus 14. When we took the log of both sides of this expression, that got us 14. Because log of 1 times 10 power minus 14 will give you 14. The negative log, sorry. Negative log, it's going to give you 14. So that's where 14 came from. I'm using this expression, which is, okay, this expression, that pH plus pOH will always be equal to 14. Or you can think it's this thing exactly, but expressed in log. Okay, H plus 1 concentration multiplied by OH ion concentration will always give you 1 times 10 power minus 14. So the 14 is just a constant. It's because KW is a constant. KW is always a constant. Or if 14 change ho jayega. Remember, equilibrium constants, they change with temperature. So if you change temperature, the ions will ionize more and the concentration of the ions will be greater. So this number will be bigger in that case. So this is 14 only under standard conditions, room temperature. Koi aur agar temperature hota na, to it would have been a different number. So it could have been 15, it could have been 16 as well. तो वो वहां से है. चलो ठीक है, we'll practice more questions in the next class. ठीक है, चलिए, okay everyone. Take care, Allah Hafiz.